welcome all guys, friends. Today I'm going to explain the last problem of this four-barling mechanism, and this time it is based on our suitable movement of our rigid body. Rigid body means which will not face any deformation regardless of any force has been applied on it. Okay. So sometimes it becomes a necessary part that that we want we want a certain mechanism which will be fulfilling our required job. Okay, sometimes like you can see the uh, car wipers. Okay, they will be showing you some it will be wiping our whole windshield, car windshield. So means how we want the desired function to be done, or sometimes we want like to not to clean our the blackboard by means by hand. We will be fixing a duster in that mechanism, and we will be operating it, and we will be cleaning it. And sometimes you can see the oscillating fan, means in the rooms and in the old age homes you will be seeing a rotating fan, means it will be rotating fan. It will give you the fan will be giving you suitable directions of air. You will be feeling that like, yeah, this guy is getting fan means getting cooler, I am not getting the cold breeze. So to get the means just for the sake, like here the both will be getting the equal airs, means here you can understand like they can get the same air, feeling the same cold. So means I have explained you this. So this mechanism in synthesis will be based on the what I have explained, the our required job. It will be fulfilling our required job. So for that we will be imagining 2 points, minimum 2 points on the fixed point, means sorry, in the rigid body. Rigid body means our means the required output duster or the car wipes, or by wipers, or the duster working, or the oscillating fan movement. We will take this as a coupler. I told you na, in the 4-bar mechanism, this this will be this two will be our fixed link, this will be input crank, this will be our output crank, and this will be coupler. So the 2 points which will be initially taking will be acting as a coupler. Okay. So here, okay. So I have taken the desired this was my desired position, like this thing. My desired position was this, and I got this mechanism. Okay, we don't actually we avoid this drawing the line of frame, because sometimes it looks something means for simplicity purpose, like it is understandable that understood that both these points are fixed link, means those 2 points will be fixed, so we can draw by not drawing these lines. So here the procedure is very much simple than the other 3 problems which I explained in the last 3 videos. What here we will be doing is we will take any 2 desirable points, P1 and C1 on the rigid body, this. And if you want the dimension of this, I have taken the dimension as 1 here, and distance between this is 1, and this one is also 1 mm respectively. Okay, and Distance between this B1 C1 is 3 mm. Okay. This one between is 3 mm. So I have taken the another position B2 C2, and the relative position won't be disturbed because the links are rigid but the mechanism is not the rigid. Okay. So we got this thing, and here I was telling you in the previous video that we will be having certain situation where we will be getting the 3 position. We need that particular position where to fix that. Okay, we can't draw the infinite. So we will join the B1 C B2 and B3 B2 with dotted lines. Okay, with dotted lines. Again we will follow the procedure of drawing this perpendicular bisectors, and here we go. We will meet at A. This A was not fixed first of all. We started with B1 and C1. Okay, we have not started with A B. Okay. Now again we will take the C1, C2 and C3. We will again follow the same procedure for drawing the common normals, and we will meet at T. Here the interesting part is that as we know that the fundamental point that the links are the rigid, and of course the PC which we took in the rigid body is also rigid body. If we take roughly we can take, okay, so the distance here B1 C1, B2 C2, B3 C3 remains the same as 3 mm. So we took all dimension again in mm. Scale is 1:1. Scale 1:1 means whatever we'll draw on the paper will be same reflected on the real life. So these are the steps which I explained here, and our links after drawing the link mechanism, our link lengths are AB1 92, B1 C1 30, C1 D 86, and AD 36. This is 36. This is 92. This is 92. This is 86. Oh, this is 86. Oh, sorry. Yeah. I told it's 3 mm. No, it's not 3 mm. This is 3 centimeters, and if you convert it is 30 mm. Okay. So this ends our synthesis of 4-bar link mechanism by different. We learnt the various processes. Like we first. Okay, I will write here. Okay. I will write here. We first learnt by first path generation. Like we want the suitable path. Okay, that was the first question, and we learnt the function generation method. That 2 questions we solved. Okay, second and third. By function generation, like we have inputs and we get outputs, points type. Path will be like we will be getting the certain part, like it will go by circular. Sometimes it may be circular, sometimes it may be straight line, or sometimes it will be some curvy play, means like this. Sometimes it should be straight line, sometimes straight line, sometimes I will show you. Okay. And the third one was motion, means we want certain motion to be direction, which was 4th. So this ends our all the series of means generating 4-bar link mechanisms, and I will show some of the application of it. Okay, don't miss